I hope this will help in your preparation for your summative test number 1. Okay? So you have learned that the speed of all electromagnetic spectrum waves is equivalent to 3.0 times 10 to the 8 meter per second. And to get the speed of light, we we've learned also, or we've discussed rather, that it's equal to frequency times the wavelength. And using that equation, we can manipulate some of the uh, key components in order to arrive at the um, desired known, or unknown rather, desired known in the problem, unknown. Now, so if we have frequency, how do we solve that? Frequency, we use the equation frequency is equal to speed of light divided by, this indicates division, wavelength, right? And now if you're asked for the wavelength, speed of light divided by frequency. And you get to see here the corresponding units that would express the key components of the equation. Okay? Next, in order to get the energy, we make use of E is equal to H times F, or E is equal to H times V. V or F both means its frequency. This is the quantum energy of a photon. And H represents Planck's constant. And I've presented this again to you, okay, to remind you that, again, we will use this value completely. No need to round off to 2 decimal places yet. And to get the energy, we manipulate this equation to solve for the frequency if energy is known in the problem. Okay? So take note that these two equations, we will make use of that in working for the problems presented in the formative assessment. So we have here question number 1. Excuse me. Question number 1 is about the yellow light given off by a sodium vapor lamp used for public lighting. Has a wavelength of 589 nanometers. What is the frequency of this radiation? I've mentioned last time that in order for you to organize your thoughts, we make use of the gas form, given, as, and solution. So given the problem, allow me to write it down here. Given is equal is wavelength, and that is lambda is equal to 589 nanometers. We're asked here for the frequency. So we're given the wavelength of the radiation and asked to calculate for the frequency. You may use F if you want to, okay? So the relationship between the wavelength and the frequency, which is unknown, is given by the equation of the speed of light. So you have learned that speed of light is equivalent to wavelength times the frequency. With this, we manipulate the equation to solve for frequency. Frequency is equal to the speed of light divided by lambda, after which we substitute the value. So we have learned that C is equal to 3.00 times 10 to the 8 meter per second divided by lambda, that is 589 nanometers. Please take note that we need to check if we are expressing the units of the certain variable. So we have here speed of light meter per second and wavelength is in nanometer. We cannot cancel the unwanted unit because the other length is expressed in meter. Thus, we add another conversion factor here. Okay, so 1 nanometer, and nano means 10 to the negative 9. So that's what nano means, meter. By this, we can cancel the unwanted units. Nanometer divided by nanometer is equal to 1. Meter divided by meter is equal to 1. Okay, we are left with this per second. Okay, we're left with per second. Per second is the unit used to express frequency. That's clear? Therefore, if we are going to calculate this one, okay, we will get the value of, we will have the value of 5.09 times 10 to the 14th per second, or that is in Earth. Okay, 5.09. And we agreed that our final answers should be expressed in 2 decimal points, and that's the time you're going to round off. Okay, so box the final answer so that I can easily get to see that as I check your work. Okay, the frequency, the high frequency is reasonable because of a short wavelength, and the units are proper because frequency has units of per second or Earth. Okay, kindly check uh, what were your answers, how did you present it, and make some corrections, please, and learn from your mistakes if ever you did not get it right. Okay, so next we proceed to uh, problem number 2. I'll be just presenting problem 1, 2, and 5, and 3 and 4 is for you to review. Okay, so allow me to clear the screen. Question number 2 is um, about radio station broadcasting at a frequency of 590 kilohertz. So it's asking here the wavelength of the radio waves. Therefore, again, we write the given 590 kilohertz. We need to convert kilohertz in order to cancel per second because we're asked of the wavelengths here. Therefore, we can convert easily in the given part. So we have 1 kilohertz. Kilo means 1,000 hertz. We cancel out kilohertz because it's equal to 1. Therefore, we will get here 5.90 times 10 to the 5th hertz, okay, or per second. Now, we are asked to solve for the wavelength. So to do that, we manipulate again the equation of the speed of light in relationship to the frequency and wavelength. So we have wavelength is equal to the speed of light divided by the frequency, right? Divided by the frequency. Therefore, we have 3.00 times 10 to the 8 meter per second divided by our frequency is 5.90 times 10 to the 5th hertz. Change it to per second. Okay, so that we can cancel the unwanted unit. So we cancel out, okay, that gives us the value also. We're going to use your calculator. That gives us 508.47. Express answers in 2 decimal places for uniformity in the presentation of the answer. Okay, and what unit is left here? We have meter, which is used to express wavelength. So do not forget to place the unit. Okay, I hope you're able to get that. Clear? Next, let's go to item number 3. Let me clear the screen. A laser emits light, or as what I've said, I'm sorry. So what I've said, we're going to use number 5. Okay, 3 and 4 will serve as your review or review guide for you. So let's have number 5. A certain electromagnetic wave has a wavelength of 625 Newton, nanometer rather, nanometers. What is the frequency of the wave? What region of the electromagnetic spectrum is it found? So again, we write the given. Given in the problem is the wavelength, which is 625 nanometer. You're asked to solve for the frequency. Frequency is unknown. So solution, frequency is speed of light divided by lambda. Okay? So we have frequency is 3.00 times 10 to the 8th meter per second. Okay, that's the speed of light divided by our 625 nanometer. Again, we need to convert this nanometer to meter so that you can cancel the unwanted units. We have 1 nanometer divided by 10 to the negative 9 meters. We cancel meter to meter, nanometer, nanometer. That's it. Okay. So with this, our answer here is frequency is 4.80, 4.8 times 10 to the 14th per second, and that is in Earth. Box the final answer, please. And then we have a second question. You need here the chart of the electromagnetic spectrum. What region of the electromagnetic spectrum is found? You may use also the frequency, but since it is 625 nanometer, so we have here a wavelength. These are in micro. And then here you get to see the frequency. And of course, looking at another value presented here are the wavelengths of the visible light, specifically of the colors. So we have 625. Okay. So therefore, what region of the electromagnetic spectrum is it found? It's the visible region. Okay. You may add also red, orange, Roy, Jabib. So we have orange light. Right? That can be, but the best answer here is the visible region. Okay? That's how you're going to answer question number 5. And again, you need the chart for this type of problem since it's asking you of the region. Okay, 10A, I hope that's clear. Next, your common mistakes encountered. Okay, when I check your work, okay, please organize your thoughts and easy for you to pick up the proper equation. Use the gas form. Okay, please show the cancellation of unwanted units. Next, don't forget the necessary conversion factors to convert to the desired unit. Okay, and of course, we round off on the final answer, not as we go on the process. Is that clear? Okay. Then, dear 10A, if you are asked to solve, I just would like to explain. If you're asked to solve for or to solve an equation, a word problem, a problem, science problem that involves calculation, please familiarize yourselves with this rubric. All ideas presented are complete and organized, and the solution is correct. You will get 4 points for that. So, to help you get that 4 points completely, do the GAS form and then present the correct answers. Okay, round off properly as we had agreed. We're going to do that in the final answer. All ideas are presented, okay, are all ideas presented are complete and the solution is incorrect. Or this can be stated in the other way around. All the ideas presented are incomplete and the solution is correct. So therefore, you still get 3 points. Some ideas presented are incomplete and solution is incorrect. You will get 2 points. One, okay, if um, most ideas presented in the solution are incorrect, and 0 if there is no attempt to answer the question. I hope you're clear with item number 3 or the 3 points. Okay, we can do that vice versa. Here, so that ends my feedbacking with regards to um, eh, frequency, wavelength, and speed of light. Okay? Feel free to ask Miss Michelle if you still have any concerns. With regards to this one, please review the materials, okay, the PowerPoint presentation I had given to you to discuss on how to calculate the energy. Something for you to remember also, you know, when I give a formative assessment, some of these items were found in the internet, but not all, okay? Make it as a reference guide to answer the worksheet. But of course, learning will not take place if you will simply copy. You are encouraged to learn the process, okay? Because formative assessment allows you to practice, not to copy and paste. Okay? Remember that. So, I hope this presentation will help you as you prepare for my summative test. Good luck and aid.